This is chapter 5 of Exemplar, Continuity and Differentiability. This is example 22. Examine the differentiability of the function f defined by fx is equal to 2x plus 3 if x lies between minus 3 to minus 2, and this is equal to x plus 1 if x lies between minus 2 to 0, and this is equal to x plus 2 if x lies between 0 and 1. The doubtful points here are minus 2 and 0. So we are going to find the differentiability at minus 2 as well as 0. First we will find the differentiability at minus 2, then we will find the differentiability at 0. When we will find the differentiability at minus 2, we will find left hand derivation as well as right hand derivation. For left hand derivation at minus 2, we will take this function 2x plus 3, and for x is equal to minus 2, we will take this function. And for right hand derivation at minus 2, we are going to take this, we are going to consider this. For that, we will take this function. For x greater than minus 2, we will take this function. For x equal to minus 2, we will consider this function. And when we will discuss the derivation at 0, left hand derivation at 0, so we will consider this function. For x is equal to 0, we will consider this function. And for right hand derivation, we will consider this function for x greater than 0, and we will consider this function for x equal to 0. So इस सम के अंदर ये थोड़ा कन्फ्यूज़न रहेगा कि फंक्शन कौन सा लेना है. कन्फ्यूज़न की बात भी नहीं है. यहाँ पर आपको इस चीज़ का ध्यान देना पड़ेगा कि फंक्शन कौन सा लेना है. अगर आप फंक्शन ठीक से नहीं लोगे तो आपका सम गलत हो जाएगा. तो इसको आप जब इसका फॉर्मूला लिखोगे डेरिवेशन का, लेफ्ट हैंड डेरिवेशन का और राइट हैंड डेरिवेशन का, तो प्लीज़ आप कौन सा फंक्शन ले रहे हो तो वो ध्यान से लिखना. सो लेट मी स्टार्ट हियर. दिस इज द फॉर्मूला फॉर डेरिवेशन. एफ डैश एक्स इज इक्वल टू लिमिट एच टेंड्स टू 0 एफ एक्स प्लस एच माइनस एफ एक्स अपॉन एच. The only doubtful points for differentiability of fx are x is equal to minus 2 and x is equal to 0. First, we will find the differentiability at x is equal to minus 2. So, formula is left hand derivation at minus 2. It means f dash minus 2 is equal to limit h tends to 0 minus f minus 2 plus h minus f minus 2 upon h. Now, I have written the function here. If x less than minus 2, I have taken this function 2x plus 3. If x is equal to minus 2, I have taken this function x plus 1. For left hand derivation, f minus 2 plus h is equal to, you are going to substitute this value in this function. So that is equal to 2 minus 2 plus h plus 3 minus f minus 2. You are considering this function now. So substitute this value in this function. That is equal to minus 2 plus 1. So limit h tends to 0 minus 4 plus 2h plus 3 minus 1 upon h. Limit h tends to 0 minus 4 plus 2h plus 4 upon h. Minus 4 and 4 is cancelled. So you are left with limit h tends to 0 minus 2h upon h. H and h is cancelled. This is equal to 2. So left hand derivation f dash minus 2 is equal to 2. Now right hand derivation at minus 2, f dash minus 2 is equal to limit h tends to 0 plus f minus 2 plus h minus f minus 2 upon h. Here we are going to take the function fx as x plus 1 if x greater than equal to minus 2. We are going to have this function now. So limit h tends to 0 plus, substitute this value in this function. You will have minus 2 plus h plus 1 minus 2 plus 1 upon h. Limit h tends to 0 plus minus 2 plus h plus 1 upon h. Limit h tends to 0 plus h upon h, that is equal to 1. That is equal to 1. So left hand derivation at minus 2 is 2. Right hand derivation at minus 2 is 1. So left hand derivation at minus 2 is not equal to right hand derivation at minus 2. Therefore, Therefore, f is not differentiable at x is equal to minus 2. Now, we will discuss the differentiability at x is equal to 0. Again, we will find left-hand derivation as well as right-hand derivation. So, left-hand derivation f dash 0 is equal to limit h tends to 0 minus f0 plus h minus f0 upon h. Now, for x less than 0, we have this function x plus 1. For x is equal to 0, we have this function x plus 2. So, limit h tends to 0 minus, here we will have h plus 1 minus 0 plus 2 upon h. So, f0 plus h, we will have this function. For f0, we will have this function. Limit h tends to 0 minus h minus 1 upon h, that is equal to limit h tends to 0 minus h upon h is 1 minus 1 by h. Now, this function is not defined at h is equal to 0, which doesn't exist. So, this function doesn't exist. Hence, f is not differentiable at x is equal to 0. Here we won't find the right-hand derivation. Since left-hand derivation shows that it doesn't exist, so there is no need to find right-hand derivation. यहाँ पर हमने लेफ्ट-हैंड डेरिवेशन से ये देख लिया, तो यहाँ पर हमने देखा कि ये एग्जिस्ट ही नहीं करता एट एक्स इज इक्वल टू 0. सो इट मीन्स कि f आपका डिफरेंशिएबल नहीं है 0 पे. तो यहाँ पर हमें राइट हैंड डिफरेंशिएबिलिटी नहीं निकालने की ज़रूरत. तो आपका लेफ्ट हैंड नहीं बता दिया कि एग्जिस्ट नहीं करता, तो हमें कोई ज़रूरत नहीं है कि हम राइट हैंड डेरिवेशन भी दिखाएं. अगर ये एग्जिस्ट करता तो फिर हमने राइट हैंड भी निकालनी थी, फिर हमने चेक करना था कि वो दोनों इक्वल है कि नहीं है. बट सिंस यहाँ पर ये एग्जिस्ट ही नहीं करता, तो राइट हैंड डेरिवेशन निकालने की ज़रूरत ही नहीं है. सो देयर इज़ नो नीड टू फाइंड राइट हैंड डेरिवेशन. Since this shows this doesn't exist, it means left hand derivative doesn't exist. So there is no need to find right hand derivation. Only this shows that this is not differentiable at x is equal to 0.